Okay, guys, we're back for 11.2. Use properties of tangent of a circle. So our first one is to draw a chord. Remember, a chord has endpoints on the circle, and it's a segment. You can draw this almost anywhere as long as it ends on the circle. So that's an example. We have another one over here. Our next one says draw a tangent. A tangent is a line that intersects the circle at just one point. There are infinitely many tangents on here. I can't draw this one exact, so let me redo it. And then make sure you put the arrows on the end because it's a tangent line. We're going to learn about something else with tangents today, but this one's just a tangent line. So arrows on the end. And then describe how the radius and the diameter are related. The diameter is the length of two radii. So remember, our diameter, let me do this in the color that might stand out, goes across our circle. No, it didn't take. You have that center of your circle. This is one radius, and this is another radius. And so it's two radii there. Now we have some theorems. Feel free to pause this to make sure you write them down. So theorem, if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So this is saying that if you have a tangent line, you can draw a radius in that will be perpendicular to it. And this will allow us to solve for different portions of the circle and the tangent lines. And then the next one is theorem. In a plane, if a line is perpendicular to the radius of the circle at the endpoint of the circle, then it is tangent. So those are kind of converses of each other. So now if you see that it's perpendicular, and it's at the endpoint, then you know it's going to be a tangent line. And the last vocab word for right now is tangent segment. This touches the circle at one of the segment's endpoints and lies that is aligned on the line that is the tangent line to the circle. So what this is just part of the tangent line. It's just a segment in there where that part where it touches the circle is one endpoint, and then another point on the line is the other endpoint. Okay, next up, what you see happening here is we have to use the Pythagorean theorem. You've got a right triangle. You know the hypotenuse, and you have two sides. When you do this, what you see is you're looking for the radius. They're representing it with the x. You have the tangent segment, which is 15, and then you have the end of the tangent segment to the center of the circle, which is 17. So we have to use that a squared plus b squared equals c squared. Remember, the c squared is the part opposite of the opposite of the right angle, which means that the c is the 17. The other two you can substitute in. Okay, so we have x squared plus 15 squared is 225 equals, I've got to put in that 17 squared again. Okay, 298, 289. We're going to subtract over that 225. X squared equals 64. To get that x by itself, we're going to square root both sides. So when we square root both sides, we get x equals 8. So we know the radius here would be a length of 8. This next one's a little tricky. So here, we're doing the Pythagorean theorem again. You know that the hypotenuse is the side opposite of that right angle. But here, when you look at it, at first look, it looks like that right angle, or that hypotenuse is going to have a length of 25. But really, we see it's that 25 here and the r. So we know that that's the same thing as 25 plus r. So when we substitute this in, we have a squared plus b squared equals c squared, where a squared, let's call that r, and b squared is 45 squared, equals 25 plus r squared. You guys could have written that as r plus 25 squared. That's probably what I would do. I'm going to do that work up here, just so I have some space. 25 plus r squared is the same thing as 25 plus r times 25 plus r. We're going to distribute, so we end up with 625 plus 25r plus 25r plus, last one, r squared. You end up with 625 plus 50r, okay, plus r squared. So I'm going to go down here, I'm going to rewrite this in. R squared plus 45 is 2025. And we get r squared plus 50r plus 625. And now we're just combining like terms. The first thing I'm going to combine are my r squareds. Subtract over an r squared. When this happens, they go away. Okay, and then I'm going to subtract over my 625. So minus 625. I get 1,400 equals 50 r. I divide each side by 50. R equals 28. So no square rooting there because our squares subtracted out. So we're left to just r equals 28. Let's go on. Okay, we have another theorem. If the segments from the same outer point outside the circle are tangent to the circle, then they are congruent. So if you have lines that connect at the same point, in this case it's S, and are both tangent to the circle, then these two have to be congruent. Okay, let's go utilize this. Okay, so we look at our first one. We see we have the same outer point. Let's see right here. They're both tangent to the circle, only hitting once. So that means we know they're both going to be congruent. So that means X has to be 20. Same thing's happening over here, and which one I think would be 4. You see that you have that outer point, both tangent to the circle. So that means these are congruent. So if we're going to solve for X here, 2X plus 4 equals 18. Subtract over our 4. 2X equals 14. Divide by 2. X equals 7. Okay, our next one up, same idea. Outer point. These two have to be congruent. 10x minus 4 equals 4x plus 14. Add 4. I get 10x equals 4x plus 18. Subtract 4x. I get 6x equals 18. Write that over here. 6x equals 18. Divide by 6. X equals 3. Okay, guys, let me know how this is going if you have any questions.